So welcome to lesson 38. We're in 38A where we're going to talk about fundamental counting principle and permutations. So to review permutations, that's the arrangement of members of a set in a definite order without repetition. So that means we can only use the members of the set one time or the number of times that it is written. So in this set, we have three members in the set, A, B, and C, right? And so the most numbers of ways that we can write them without repeating something that's only used one time, like A is only used one time in ABC, and B is only used one time in ABC, and there's only one C in ABC. The number of different unique arrangements without repeating an arrangement is 6. And we know that because we've written them all out for us here. When A is the first member, we can either have B next and then C, or C next and then B. When B is the first member, we can only have AC or BCA. And when C is the first member, then we can only have CAB or CBA. Those are the only permutations that are unique. There's only 6 of them. Now we can use the factorial method to derive the number of permutations without having to write them all out like this. We only have to count the number of members in the set. So in ABC, there's 3 members in the set, and we use our factorial button, or 3 factorial, 3 exclamation point, which ultimately is just starting with whatever number we have for the members in the set and multiplying it by its the next factor would be 1 less than that. So in this case, it would be 3 times 2 times 1. Well, that's 6. And there are 1, 2, 3, 4, 5, 6 unique arrangements or permutations with the set ABC. That's permutations. So the difference between a permutation and the fundamental counting principle: with permutations, there is no repetition allowed. The fundamental counting principle allows its unique arrangement, but it allows repetition. So unique arrangements allowing repetition of members limited to the number of members in the set. So for permutations, we have 3 members in the set. We could use any one of the 3 members in the first position. In the second position, we're limited to one of the 2 remaining members, and the third position has to be whatever's left, because there's only 3 positions and there's 3 members, and we're not going to allow repetition of this first one that we chose. So we only have 2 left, right, for the second, and then there's 1 left for the third. And we use the factorial button, or the factorial method, using these as factors to give us the total number that there is possible. And then when we did it previously for A, B, and C, we found there were only 6 possible permutations or arrangements of those members without repetition. The fundamental counting principle, on the other hand, allows you to repeat. So I could choose A for the first one, A for the second one, and A for the third one. The only limitation is that if we have 3 members in the set, we can only have 3 factors. So that's the same thing as saying I could have AAA, AAB, AAC, ABA, ABB, ABC, right? ACA, ACB, and ACC. Those are all of the repetitious permutations when I choose A for the first location. Now, if I choose B for the first location, it's going to be the same thing. It's going to be BAA, BAB, BAC, BBA, BBC, BCA, BCB, and BCC. Those are all the possible permutations or arrangements for B when I allow B to be duplicated, and I also allow the other letters to be duplicated in that arrangement. And the same thing for C. So I could have CAA, I could have CAB, I could have CAC, I could have CBA, I'm sorry, there should be a C right here, CBB, and CBC. And then I could have a CCA, CCB, and CCC. So the way we calculate that is to identify the numbers of the set, and then that becomes the factor or the base, and then the numbers of the set become the exponent. And that would be the format that you use. So if you had a 4-member set, then you would say 4 to the 4th power would be the number of arrangements that would allow repetition of the members, but would be limited to the number of members in the set. So this number, and then that becomes the exponent of that number. So for instance, let's do example 38.1. Let me clear the page. Make sure you have all this written down. 38.1, and it is asking us how many different ways can the numbers 3, 5, 7, and 8 be arranged in order if no repetition is permitted. So no repetition. So we're looking for a permutation. So that means we're going to use the factorial method. So if we've got 4 different numbers here, it doesn't matter what the 4 are. What matters is the quantity. So we would have a 4 factorial, which would be 4 times 3 times 2 times 1, which always equals 24. So we could have 24 unique arrangements if we do not repeat any of these numbers. All right. So now let's look at 38.2. This one is saying how many 4-letter signs, so 4 letters, out of the word equal if repetition is permitted. So with repetition. So this is saying there's going to be 4 members in the set. We're only going to have 4 positions, right? But we have 5 letters. So that means we're going to use 4 factors beginning with the number 5. So 5 times 5 times 5 times 5. 4-letter sign, so that's 4 letters, and we're going to allow repetition. So we could use this one 5 times, or this one 5 times, or this one, or this one, this one. However many times we want to use it in each of the positions. We could double them up. It doesn't matter. And then this is going to be 625, and this is going to be the fundamental, or the FCP, the fundamental counting principle. So whenever it says with repetition, you're going to take the total members of the set and multiply it by each other the number of times that it tells you the size of your positions is, or it's going to tell you how many positions. So this would literally be 5 to 4 positions. This is your exponent. This is your exponent because it's telling you you only want 4 letters, but these are the members of the set that you can choose from. So this is your factor. Let's do 38.3. All right, so we have a multiple choice test, has 8 questions. All right, so there's 8 questions in a multiple choice test. There are 4 possible choices. Let's say they're A, B, C, and D for each one. How many different sets of answers are possible? So this is one of those where you have to look at the question and decide for yourself, does this have repetition or does it not have repetition? Well, Obviously, you've got 4 members with 8 questions, so some of these are going to be repeated, right? You could only do them uniquely 4 times, and then you got 4 more questions that you've got to pick from A, B, C, or D. If it's a test like this, all the answers might be A, all the answers might be B, or it's going to be a combination thereof. So this is going to have repetition in it, just by default of what type of scenario you are given. A lot of times you're going to have to infer, is it with repetition or is it without repetition? This one is with. Now we have 8 questions, 4 choices. That means that we're going to have 4 is the number of members in the set. That's our factor. And the number of positions that we have available is our exponent. So this is going to be 4 to the 8th power. So when we do 4 times 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 4, that is going to equal 65,536, or you just put it in your calculator with that little XY button, right? You put in 4, you hit the XY, and you put in 8, you hit equal. And that is going to give you your number. Or you can just say 4 times 4 times 4 and count 8 times. You'll still get this number. Last one, 38.4. I think I can do it right up here. How many 3-letter signs can be made from the letters in the word numeral? So we have 3-letter signs. 3-letter signs. The word is numeral. But we have no repetition. It's telling us that. It says no repetition. So if there's no repetition, by default, if it says no repetition, this is factorial. So we're going to lose a factor each time, or subtract 1 from our factor each time. So if we have 3-letter signs, that means we have 3 positions here. 3 spaces, and so we need to have the total number of options for the first one. So 1, 2, 3, 4, 5, 6, 7. We could choose any of those 7. For the next one, after we cross out 1, let's just say we cross out this one, all we have left are 6. And then for the next one, all we have left are 5 to choose from. So 7 times 6 times 5 is going to give us 210. Those are our options. Those are the number of 3-letter signs we can make without any repetition. Does it make sense how we're doing that? So that is all we have for 38A. I want you to do the practice problems associated with that, and then we'll pick up in 38B.